Ciao friends, and welcome to a new Unplugged video from SQL BI. In this video, I want to talk about the auto-exist feature in Summarize Columns. And I will do that by showing you how I answered to a question that appeared in the Power BI community forum. A user, the Dark Prince, asked a question about why a percentage produces different results depending on the slicer that you use to slice the numbers. Same data, same formula, same everything, just a difference in the slicer and the numbers are different. Now, typically in Unplugged videos, I show you how I reach the conclusion about the problem and how I solve it. This time this is not actually needed because as soon as I read the question, I knew the problem was auto-exist. And actually, in the question, the user itself says, well, I guess the problem is auto-exist. The thing is, auto-exist is such a complex problem and such a complex behavior to understand that I thought that recording an Unplugged where I try to explain auto-exist using the data that the user provided makes a lot of sense. So we will first look at the question, reason on top of it in order to focus on the problem. Then I will describe how the numbers are being computed in a theoretical way, just writing doodles on the whiteboard. Then, since during this entire process I will not have written a single line of DAX code, and any video without writing DAX code is just boring, we will investigate a bit further. So we will write DAX queries in order to understand when auto-exist happens and how to avoid auto-exist from happening. Hopefully this will help you in understanding, first of all, what auto-exist is and how to discover if your specific calculation might be affected by that behavior. Auto-exist is one of the behavior that I call the DAX shenanigans, behaviors that are really hard to understand and typically drive you crazy. But it's useful to know about them because once you know your enemy, you also know how to fight and how to solve your problems. That's long enough as an introduction. Let's start by looking at the question and then we start reasoning together. So we have the question here that appeared in the Microsoft Power BI forum. Let me zoom in a bit less. Okay, now we can read that. The Dark Prince asks for help. Now, I mean, if the Dark Prince asks for help, here I am. The question is, all returns different values for categorical and range type slicer. Hi everyone, I had a problem. We need to check this PBIX that we will do in a few seconds. But the problem is that the result is displayed on two pages which are different even though the underlying data, DAX measures definition are exactly the same. The only difference is in the slicer that are used in the reports. And then other considerations which are not so important. Another important point is that the user already read the article about auto-exist and he thinks that the problem is auto-exist as it actually is, but he still has problems in understanding the details. Now, before moving further with the topic, why did I answer this specific question? Well, first of all, I was summoned. The Dark Prince actually asked for my help specifically. But beside that, it's important that the question was very well posed, very specific. We had a reprofile with all the data that was needed to investigate on that. So it's just the perfect question to try to answer to. The only thing that was actually missing is, well, some bit of DAX knowledge in order to understand the details, and that is what I can provide. So let's go back to the article. We have the link to download the file, and that's all I have already done. So we can get rid of that and look at the file. On this file, I can explain the problem. The problem is that we have this matrix that is showing the subject and the initial data. First of all, what is the data, the underlying data? Let's zoom again. We have a single table that contains a subject, the student, the marks, these are probably tests of any kind of test, answers to test, and then bucket. Bucket is a calculated column that checks whether the value of marks is less than 50 or greater than 50. So 45 is less than 50, and so it's categorized as less than 50, whereas, for example, 53 is greater than 50, and so the corresponding column is greater or equal than 50. So this is the table we have, just a bunch of rows. And on this table, we have the matrix that slices by subject and provides the initial value. Initial is a calculation. Let me look at that with a bit of a larger font. That computes the numerator, the sum of the marks, the denominator as the sum of the marks for all the subjects, and then divides one by the other. Probably you want to know the sum of all the marks of all the tests and do a division of one against the other. Whatever the reason is, that is not important. The code by itself is quite simple. Here I'm slicing by subject. I filter only physics. I'm slicing by marks, so on the number, the real number of marks, between 23, which is the smallest number, and 49, so we are less than 50. And we show initial, 60.18%. The problem is that the same calculation with the same values with a slicer that instead of slicing by the value of the marks, slices by the bucket provides 46.90%. The slicer on physics is the same, the values here are the same, the measure is the same, the data is the same, but the numbers are different. Now, the problem might be everywhere. You see that it's likely that he already did some tests because we have a measure for the denominator, a measure for the numerator, because he probably checked them, and we can try them. We can put the numerator, we can put the denominator, and we have a numerator of 68, denominator is 145. Let's go in the other report. We put the denominator, the numerator, that should be first. The numerator is still 68, same as we have here. The denominator is 113 and 145. So we basically know that the problem is at the denominator level. The numerator is always correct. And at the denominator, we are using all. Now, there are a lot of details that clearly drive us to AutoExist. First of all, one table only. That is the major culprit of AutoExist. Then the usage of all that removes a filter from one of the columns that are being used in the matrix. That is the perfect scenario where AutoExist is a problem. But we need to understand what AutoExist is. So instead of using the file that the user provides, I created a slightly different version because I just removed some rows. I was not interested specifically in chemistry. I only wanted physics and maths because these are enough to show the problem. And because I had the file, I could do that. And then I just arranged the report in a different way. Let me show you the file that we are using to work and learn about AutoExist. I have the code here that is only convenient, so I don't have to open all the time the code. The same matrix, and here I have the data, because this way I do not need to go all the time to the data view in order to show you some data. And the slicer are the same. The value that I have here, all subject marks, just computes the sum of data marks for all data subjects. It's the denominator that we had in the previous file. And it shows 113 here, where I'm filtering with the marks, and it is showing 145 here, where I have the same filter, but I'm filtering by bucket. Now, the thing is, we need to understand why we have 113 or 145. As I said, the problem is AutoExist. In order to understand why the problem is AutoExist, instead of working with Power BI, I just start reasoning on top of bitmaps and drawing with the whiteboard in order to understand exactly what is happening. So we first do a theoretical introduction to AutoExist, and then later on we will investigate further on the code. So let me turn on the whiteboard and select it, I guess. This is it, yes. Okay, now this is just a bitmap that contains the same report we were looking at earlier. And we have the formula here. So we have the formula, we have the matrix, the data here, and our two slicers. Let's try to understand what is happening here, why 113 is being computed. We have a slicer that is filtering the subject. So this is the first slicer that is actually filtering physics. Now the filter is on physics, so it is filtering this column, and it is filtering only these rows. Then we have another slicer that is filtering the marks, all the values between 23 and 49. So what we would expect it to do is filter all the values between, yes, these are the values, which are less than 50. Now we have two different filters, one on the subject, one on the marks, and the intersection of the two is only 2 rows. These are the 2 rows which are used for the calculation. But at this point, our DAX code starts to work, and the DAX code uses calculate and does all on the data subject. Now, what does all do? All removes a filter from a column. And because we have a filter on the physics column, we get rid of it. And what remains is a filter that is filtering these values. The thing is, if we sum these values, 45 plus 45 is 90, plus 23 is 113, plus 32 is 145. Why the sum is 145 and Power BI is showing 113? Because actually, this is not what the engine did. This is a simplified version of the calculation that does not take into account AutoExist. AutoExist is a feature specific of summarized columns, and this is what it does. If you use filters in summarized columns, and those filters are using one table, the same table, so multiple filters on the same table, they are not treated as separate filters. They are treated as one filter on the columns used for the table. So one filter on the table. This is AutoExist, and this completely changes the way the numbers are computed. So let's run again through the same process, but this time taking into account AutoExist. That is, different filters on the same column are merged together as a single filter. Let's do that. We need to clear out everything and start again. As I said, now we do not consider the two slicers are two separate slicers. They are two slicers on the same table, therefore they are the same filter. So we consider these two slicers together. And what do the two slicers together do? Well, one places a filter on physics, so it's filtering this part. The other one values between 23 and 49. So the important part is because we do have a filter on physics, and the filter of physics is being used together as the filter on the numbers. Only these two values are being selected. The filter does not extend above. It does not see neither 45 nor 32. The net result is the same, because these are the only two rows which are visible under the filter context. But now it's time to start looking at the DAX code. And in the DAX code, we have all on the data subject. All removes the filter from the data subject. So what it does is that it gets rid of the filter from physics. What remains is not the selection of two rows. That is important. It's not the selection of these two rows. It's a filter on the marks. And what is this filter filtering? It's filtering values, because filters in DAX are not conditions, they are tables of values. And the values which are being filtered are two, 45 and 23. That is why any value which is either 45 or 23 in the table will appear again. And we have 45, I messed up everything, no? The value 45 here appears again, because it belongs to the values that are part of the current filter context. What will not appear is this value of 32, because 32 was not visible earlier, it's not part of the filter, and it doesn't matter that it is less than 50, it was not visible in the previous filter context. Now, if we do the math, it's 45 plus 45 plus 23, that is a 40, that is 113, the same value that is being computed there. This is AutoExist happening. AutoExist treats different filters on the same table when used in summarized columns as a single filter, not as separate filters. Now, you might be wondering why the same calculation when it uses the bucket column computes the correct value. We can check that. We can perform the very same reasoning we did on this example on the other page that contains a filter on the bucket instead of a filter on the values. And you will see that even though AutoExist is still working, it will now compute the correct value, 145. Let's do that. So we need the other report, and we know AutoExist is working now. So we know that we need to treat these two slicers as one condition together. The first is on the subject, and that is filtering physics. So this is the filter being applied. The second is on the bucket less than 50, and it's only seeing these values. The result, the net result at the end, is the very same, because we have only these two rows that are visible. But now we need to start looking at the DAX code. We have all on the data subject. What does all do? All removes the filter from the subject column. So it gets rid of the filter on physics. And what remains is a filter that is filtering less than 50. Now, here is the big difference. The filter is no longer filtering individual values of the mark column. It is filtering only one value, and that value is a string which is less than 50. Therefore, all the rows in the table that contain less than 50 will become visible. And what are these rows? Here they are. These are the two additional rows that become visible because now they are visible in the current filter context. So the final calculation, not this, but this, includes these four rows. They all share less than 50 in the bucket column. And we can easily do the math. It's 45 plus 45 plus 23 plus 32. And the result is 145, the correct number that you see on the screen. So there is quite a big difference between using a filter on the values of a column or using a filter on a column that clusters them. the behavior is the same. AutoExist is still there and it's doing exactly the same work, but filtering a column, the values of a column, makes quite a difference. Besides, the important detail here is that we are used to think that filtering values less than a number is actually a filter for less than that number, but that is not what DAX actually does, and this is important. We can take a look at that not on this, but on the previous one. Let me clear all these values, they are no longer useful. Now, the slicer that we were looking at is this one, that is filtering values between 23 and 49. You might think that this is translated into a condition that says something like marks less or equal, no, actually less than 50 as a condition, but that is not the case. When the DAX engine computes this filter, it will look at values which are less than 50, it will find only 45, 23, and the filter is not marks less than 50, but marks in, I don't remember the numbers, 23 and 48, 23 and 45. And this is super important. Any filter in DAX is always a table of values that is used as a filter on the column. There is nothing like a Boolean condition. All filters are just sets of values. Now, as I promised, all this theoretical description was needed in order to understand the problem. But still we need a couple of details. First of all, we need to understand how to get rid of the problem. And that is actually simple to do, even though we will need to start writing some DAX code. Second, I want to investigate a bit further. So we will basically repeat the same reasoning, but we will do that with DAX Studio. So we look at the queries executed and we understand the different behavior when AutoExist is there and when it is not. Let's start by solving the problem together. Now, to solve the problem, we start with the model we have. Here we have the calculation 113. We know it's wrong, and right now we also know why it is wrong. That is probably the most important part. How can I avoid the problem? The easiest way to remove the problem of AutoExist is to avoid filtering two columns in the same table. Because if the two columns belong to two different tables, AutoExist does not kick in. You have just a cross-join of all the values and the filter that behaves a natural way. So I need the filter on the marks to be not on the data table, but on a different table. And I can easily do that by creating an additional table. Because the data model right now only contains data. But I can create a new table. Let me go here and build a new table with a larger font. We call it marks, and we use all no-blank row of data marks. That produces a very simple table that only contains the values of the different marks. The important point is that it's a different table. It's no longer the same. And because it's a different table, I can build a relationship between, let's again zoom in, marks here, go there. There's just a one-to-many, many-to-one relationship, unidirectional, nothing fancy. And then the slicer, instead of filtering the marks column from the data table, it will filter the marks column in the marks table. I need to make it between, and we say between 23 and 49. And you see, we have 145. The same filter, the same condition, everything is absolutely identical, but the big difference is that now the filter is happening on the marks table and not on the data table. AutoExist this time is not kicking in, because a filter on marks cannot be merged with a filter on subject, because they belong to two different tables. Therefore, they cannot be merged together. And that is why we always say to all our users, use a star schema. Try to avoid working with a single flat table, because AutoExist is very likely to happen if you have a single table. A model with a single table is bad. It's bad for a ton of good reasons. Among the many, AutoExist. AutoExist does not appear if you place filters on different dimensions. A filter on date and a filter on product, they will never be merged together. But if date and product are two columns of the same table, then AutoExist will happen. And you have seen it's not easy to understand where the problem is and how to fix that. If you work with a star schema, AutoExist is much less likely to happen. It still happens at the dimension level, but it doesn't happen so frequently. So it's very, very hard that you actually find the problem. And when that happens, so if you still have a problem, there are right now few solutions apart from normalize further and build separate tables to avoid AutoExist to happen. Now, I promised you at the beginning, how can you discover more about the kind of filters that are being used? To do that, we need to, first of all, see AutoExist happening and then find a way to discover how to write your DAX code avoiding AutoExist. There is an option if you can author DAX code. If you are using Power BI, then the Power BI engine writes DAX code for you, so you have no option and you need to change the model if you have problems with AutoExist. But if you are writing DAX code, you can avoid AutoExist by avoiding placing filters on the same table inside Summarize columns. Let's do that together. And we need DAX Studio to do that. I think I already have DAX Studio open. Let me see. Yes, and I already also have a lot of code. Actually, it's easier if we just close this DAX Studio and we open a new DAX Studio. So let me go there, external tool, and we open DAX Studio. Okay, then we go there, and here we have it. We have date and marks. We are not interested in marks, it's just a table that we created on the fly in order to demonstrate the problem. Let's first of all see AutoExist happening. So we need summarize column, we need evaluate first. We summarize by data subject, and we want a column test. It actually does the same that our test column does. So let me recover the all subject marks, define measure, put everything at the beginning, and I just call it test because it's shorter. Okay. Now, if I run this query, I obtain a number which is not what I want, because I still need to obtain 145 or 113, depending on the filter that I place. I need to filter physics and then less than 50. So we need a variable, let's call it filter subject, that does a treat as of physics as data subject, and we use that as a filter that still produce 540. but then we need less than 50. So a filter on marks that filter all data mark, where data marks is less than 50. And then we apply the filter. And if I run it, now we have 113. Now, just writing this code is useful. I have this window that does not want to disappear. Let me see if it goes away in some way. No. No way, it's still there. So the best thing that I can do is copy everything, close DAX Studio and reopen DAX Studio. Then I'll come back and explain the details. But now I have the query written. I can run it, obtain my 113. Okay, as I was saying, it's already useful just write this code because that gives you a better vision of the fact that the filter is not the condition alone. It's not just data marks less than 50. It's filter all data marks where data marks is less than 50. That is a table containing some values, very different from a condition that can be applied in different places and in different points. Let's check, before moving further, that a filter on the bucket column actually works. If I create a new variable, filter bucket, that does a treat as of less than 50 as data bucket, and instead of the filter subject, the filter marks, we filter bucket, that should produce 145. Now I want to see both at the same time. Let me gain a bit more space. So what I can do is actually take this summarize column, put it in a variable, and I call this test A. When I go back to my field, now let's use filter buckets, that's fine. And then I create another variable B that computes test B, but this time instead of filtering the bucket, filters the marks. So that goes back to evaluate A or evaluate B, that produces 113. And the reason why I did all this is because I want to see both at the same time, so I can join now the two tables, doing a natural inner join of A and B. And now I have the subject, the value for A and the value for B, and you see that they are different because the difference is between filter bucket and filter marks. Let's investigate on the wrong one, which is test B. If I just evaluate B and I enable server timings, we look at the queries which are executed by the engine. I just run it, produces 113, but now I have my server timings here. Let's go for bottom layout. And you see that we have two queries which are being executed. The first one retrieves the data marks from data where subject equal physics and marks is less than 50. Here we have the condition for less than 50, but it is merged inside together with data subject equal physics. The two conditions together are used, and what do they retrieve? They retrieve the data marks, the values of the marks where both conditions hold. And in the next query, it is computing the sum of data marks, and look again at the condition. We have this less than 50, but not only less than 50. We also have data marks in 2345. Where does 2345 come from? The reason is 23 and 45 are the two values of the marks where the subject is physics. We no longer have the filter on subject physics here because we remove that in the code. In the measure, where is we are using all on the subject, therefore we are getting rid of the filter, but we are not getting rid of the filter on the marks that has been introduced because of AutoExist. If we do the very same exercise, but this time we evaluate A, this time it retrieves okay, values where country equal physics and data less than 50, and then we have this only condition, data bucket less than 50, because this is the only value that remains. There are no further conditions that need to be applied and set. The filter already contains the value. The filter contains only one column, and that value will be found everywhere. So using DAX Studio and the profiler, you can look inside the code and get a better understanding of what is happening. Even though the problem is whenever you have AutoExist problems, it's kind of hard to use just DAX Studio because this was a very simple example with just a bunch of rows. If you have a large model or if you have a complex formula, AutoExist is still there, but it's so much harder to discover it. As I said at the beginning, you cannot avoid the AutoExist behavior. If you are having issues because of AutoExist, the only option is to change the model and avoid filtering columns in the same table. If you know that AutoExist might trust relationships that are actually not existing between different values in the same column. But if you can write your DAX code, how can you avoid AutoExist? Well, it's quite simple indeed. You need to avoid placing filters on the same table in summarize columns, because summarize columns is the only function that uses AutoExist. If you use calculate table, the problem is not there. Let me show you that. Let's go back to the code. So we created A and B. Let's create, we created A and B. I no longer remember which is the wrong one. Results. B is wrong. So let me take the code of B and we create C. C still uses summarize columns. It groups by subject, but I take the two filters and I remove them from inside summarize column and I place them in an outer calculate table. So C is the same calculation. It still filters the marks. It uses summarize column, but now the filters are not placed inside summarize column. They are placed outside with calculate table. Let's retrieve everything together. A, B, and C. I only need to name it test C. Run it, and you see that test C returns 145. The reason is summarize columns does not do AutoExist. Sorry, calculate table does not do AutoExist. Summarize column does, and it does it only when you are using multiple filters on the same table. These filters are joined together and they create the problem of AutoExist. So, as you have seen, answering a simple query, if the query is well posed and provides a good repro, becomes quite interesting. We have seen the problem of AutoExist. We discover First, from a theoretical point of view, why the problem is there and how to understand why 113 was the result. And then we played a bit with DAX first to solve the problem, and finally to understand that calculate table might be helpful if you have the option of changing your code. As I said, with Power BI, you are forced to use to change the model if you are facing problems with AutoExist. Now, I think it's important to know that AutoExist exists, because if you do not know these problems, these behaviors of DAX, then you might search for the problems elsewhere. That's why I think it's so important for every DAX student to spend time learning all the complex behaviors of DAX, what I call the DAX shenanigans. Behaviors of DAX which are not easy to understand, but they are important to know because they guide you towards the solution without wasting too much time thinking that your code is wrong. Maybe you are just hitting one of the many DAX details that are hard to learn until you actually become a DAX master. Well, I hope you liked that video and enjoy DAX, or actually for this video, enjoy DAX shenanigans.